Example number 2 says that the figure below shows a schematic diagram of a process for production of flake NaOH. So the question is saying that you want to prepare NaOH crystal or solid. So the fresh feed to the process is 10,000 pound per hour of 40% aqueous solution of NaOH. So you have your fresh feed, which is a liquid. And in this liquid, 10,000 pound per hour liquid, you have a 40% NaOH solution, meaning here that the 60% remaining 60% is your water. So when we say aqueous solution, it must always be a combination of your desired material, which is NaOH, together with the water. So that is how we call aqueous solution. The fresh feed is combined with the recycled filtrate. So this is our recycled filtrate R, from the crystallizer and fed to the evaporator, where water is removed to produce 50% NaOH solution, which in turn is fed to the crystallizer. The crystallizer produces a filter cake that is 95% crystal and 5% solution, that itself consists of 45% NaOH solution. The recycle stream contains 45% NaOH solution. To determine the flow rate of water removed by the evaporator, W, and the recycle rate for this process, so the R. Okay. So if, for example, you are given this question in your final test or any other situation, most of the time this flowchart, the process flow diagram, will not be given to you. But since this is an example, so I'm giving you this process flow diagram. So by right, if this is not given to you, based on this problem statement that was given to you, based on all the information given to you in this problem, you should be able to actually draw and label this process flowchart. So if you remember, this is our second step when we are solving for a material balance question. The first step will always be the choosing of basis. Now, since we already know that the value of feed, of fresh feed is given, so this I can say that 10,000 pound per hour is my basis. The next thing is that this fresh feed, it's combined or mixed at this point. So we can say that this is our mixing point. And after it is mixed, it is sent to the evaporator, where water is evaporated, and you can say here that this NaOH aqueous solution is concentrated. Why? Because here you have 40%, here you have 45%, and over here you will have some composition of NaOH. When it goes into the evaporator, it will become concentrated, so it will increase, it will reduce the water content by evaporating the water, and it will increase the value of NaOH in the aqueous solution. After that, you will go to the crystallizer and a filter, where your NaOH filter cake, so this is actually your flake of NaOH that is desired, and then the rest 5% is your solution that was not converted into the solid NaOH. So in that 5%, you have 45% solution of NaOH. So basically what the question is saying, that over here everything is P, right? So P here is represented for all this product value. So in your P, you have one, it is solid, and one which is liquid. And this the solid composition is 0.95, and the liquid composition is 0.05. Okay, so this is the meaning of this part of the question. From this 0.05% of liquid, in this solution you will have a composition of 0.45 NaOH, and then the rest 0.55 water. Okay, so again, make sure that even if this figure is not given to you, you should be able to draw and label completely a flowchart based on the information given in the question. Now, The question is asking us to calculate the value of W and value of R. So again, I will always advise you to draw again your diagram, and then we try to find how many systems that we can have. Okay, so initially I will have my fresh feed going to a combiner or a mixer, right, where your fresh feed here 10,000 is combined with your recycled feed, and then this thing will go to your evaporator, right? This is your evaporator where water will be evaporated. So this one you have your W, and then the 50% NaOH, and this is labeled in the question, it was given as G, will go to a crystallizer, right? This is your crystallizer where you have your product P, okay, where 95% is solid, 0.5% is unreacted, unconverted liquid. But we also know that from the crystallizer we'll have our recycle stream going into our mixer to combine with our fresh feed. Now this is the diagram. So based on this one, I can create my boundary, create my surrounding, and figure out which system I can have. So first of all, I'll say that I will have an overall system, right? This is my system number one. And then I can say that I can have a system just for this mixing point, my mixer. So this is my second system. I can say that I can have a system for my evaporating process, for my evaporator. So this is my third system. And I can also say that I can have a system for my crystallizer and filter where we produce our product. And this is my fourth system. So basically you can have four systems here. The next thing is that we want to find the value of W, right? The value of W, and this is the value of R here. So if you look at here, W, in order for us to find the value of W, we can either use the overall system, because if the overall system, I have feed, W, and product coming up, right? Or I can use the evaporator system where I have the, let's say this is, you can say that this is A, your gross feed coming in, and then water is evaporated, W, and we have your the concentrated NaOH solution, which is labeled as G. So we can use, so we can say that we can either use system number one or system number three. But how to decide whether you want to use system number one or system number three? This is where you do degree of freedom analysis. Okay, so I'm not going to do degree of freedom analysis here. You can try to do degree of freedom analysis. Anyway, I'm telling you that based on this, I would say that the easiest way for me to solve is by using the overall system. And just looking at this evaporation system, my evaporator, I know that I have more unknowns than my independent equation, because I have the value of A, I have the value of W, I have the value of G, which are unknown. So three unknowns, and I think I can only make a maximum of maybe two independent equations. So definitely I will not be able to use evaporator here to solve for my value of W. But if you can go back and try to do a proper degree of freedom analysis on the evaporator to see whether actually you can use this system or not. Okay, so for now we'll solve using our overall system. So again, I will just draw my overall system, put it here, overall. So I have fresh feed coming in where I have 10,000 on per hour of, so 40% I can put as 0.44, and NaOH I can label as 0.4.n, and then the rest is water, so I can put here 0.6 water. And then I have my coming out, I have the output here, I have the value of P, right? So this is my product where I have 0.95. So I can write here NaOH flake, our crystal or filter cake, and then 0.05 NaOH solution, which contains 0.45 NaOH and then the rest 0.55 water. And then I also have water that is evaporated, so I can put here W. So if I do my degree of freedom analysis, number of unknown is equal to the value of W, that is one unknown, P is one unknown. Now I know the composition of my NaOH and water here. I know the composition of all this NaOH, water here. And I also know the composition of water here because it is going to be equal to 1 because there is no NaOH in the stream. So I have my number of unknown is equal to 2. Number of independent equation. Since I have two species, I can make two independent equation, and I don't have any other information, whether implicit or explicit relation, but it is not necessary because I already know my degree of freedom is equal to 0. So based on this, I can actually solve this system and find the value of W and P. So here you can either do balance on the overall system, balance on NaOH, or balance on water. So you can create three equations, you can write three equations, but only two are independent. So let's say we do balance on NaOH, right? So there is no right or wrong way to start. You know that you can do three balance, you can choose whichever balance you feel like doing. So for example, balance on NaOH. So on my feed side, I have 0.4 NaOH. So 0.4 times the flow rate, the feed is 10,000. Okay, that is the only thing I have my input side. So remember again, since this is a non-reactive system, your general mass balance equation will be input equal to output. So this is my input side equal to my output side. I don't have any NaOH here, so no NaOH there. I do have NaOH here. First, I have it in my filter cake, my solid, and then I have it in this solution. So how do we write this? So first of all, I'll say that in my solid, I have 0.95 NaOH, which is times with value of P, which is my product value. Plus, I have 0.05 solution times the value of, in this 0.05, I only have 0.45. So again, I type it here 0.45. And then this whole thing 0.05 here is out of this P value. So I times the value of P. Okay. So if you look at here, by using the balance of NaOH, I can actually solve for value of P. So straight away, I can get the value of P. P is equal to 4113.1 pound per hour. So this is the value of P. So just by doing a balance on NaOH, I can actually solve for the value of P. But the question here, the most important thing that we want to find here based on our question is the value of W. So you can either do balance on water or balance on the overall system. Now for me, I think that it will be easier if I do balance on the overall system. So let's say if I do balance overall system. So for balance overall system, I know that 10,000 on my input side is equal to W, which is on my output side, plus the value of P. Now the value of P I already got from this balance of NaOH. So I can easily find the value of W. So 4113.1. So I can find the value of W is equal to 5,886.9 pound per hour. So this is the value of W, which is the first information that we were supposed to find. The next thing we want to find is the value of R. Now, if we look at back our overall process flow diagram, the whole diagram, we can see that R is actually related to system number 2 and system number 4. So for our system number 2, we have our fresh feed coming into our mixer, and then going into our evaporator, and then we say that this is the value of A. This is 10,000 pounds per hour, and then we are also mixing it with our recycle, right, R. So here we know that it is 0.4 and 0.6 W. For R here, we know that it is given as 0.45 and 0.55 water. For the E here, the mix, the gross feed, we don't know the flow rate and we also don't know the composition. So we can write here fraction of N and fraction of water, right? So before we can start solving for this one, it is always advisable, it is always recommended that we do degree of freedom. Now, number of unknown is equal to R, A, W, and mass fraction of NaOH and mass fraction of water. So I have 4 unknowns. Number of independent equation, I have 2 species, so I can have 2 independent equation, and again I have another equation which is my implicit relation between my fraction of NaOH and fraction of water, because we know that W and plus W water is always equal to 1. So this is our implicit relation. So I can say that I can have another equation here, plus 1. And then I don't have any other information. So 4 minus 3 is equal to 1. Meaning that this system as it is right now, it is unsolvable because you don't have enough information to solve for this system. Okay, so this is why we need to do degree of freedom, because if you didn't do degree of freedom, you just started to solve for this system to find the value of R, you'll be wasting your time because you won't be able to solve this system anyway. Okay, so this system cannot be used for now. Okay, for the time being, I'm not saying that it cannot be used at all, but for the time being, because we don't have enough information, we cannot use this system to find the value of R. So the next thing we have that we know the value of the equation for our system number 4, which is for the crystallizer and the filter. So coming into your crystallizer, the feed coming into your crystallizer is your stream G, right? And then you know that it is 0.50% NaOH solution, so I can put here 0.5 N and 0.5 water, right? Coming out here is my P value, which I have 0.95 flake and 0.05 solution with 0.45 and NaOH and 0.55 water. And then I have my recycle going into the mixer, and this is labeled as R, and I know that I have here 0.45 N and 0.55 water. Okay, the value of P is already known. I have already calculated from our overall system, so this is no longer an unknown. I can find the value of P. P is equal to 4113.1. So the only unknown I have here is G and R. So number of unknown, again I do degree of freedom, number of unknown is equal to 2. I have two species, NaOH and water. So number of equation is equal to 2. So I will have degree of freedom is equal to 0. So based on this, I can actually solve for this system, and then I can just find the value of R. So let's say again you can do balance on overall, balance on water, or balance on NaOH. So if let's say we do balance on overall, right, balance on overall. So G is going to be equal to, I have one input and I have two output. So G is equal to P, which is the value of 4113. So I already know 4113.1, and then the value of plus the value of R. Okay, so this is my balance of overall system. Now I can do balance on water or balance on NaOH. So let's say if I do balance on NaOH. So I know that on my input side I have 0.5 NaOH, and then the flow rate is G is equal to, on my output side I have 0.95 NaOH, which is in the solid form, times the value of P, which is 4113.1, plus I still have NaOH in this 0.05 solution. So 0.05 times 0.45 times my value of P, which is 4113.1. Okay, this is on my product side, plus the value of, I have in my recycle, I have 0.45 NaOH times the value of R. Okay, so this is my equation number 1 and equation number 2. So you can also do balance on water. Using either of these three equations, you can find the value of R. So by using this equation, you can find that R is actually equal to 3886.9 pound per hour. Okay, so the question is only asking you to find the value of R. It is not asking you to find the value of G. But you can still find the value of G if you want, or you can just stop here and this will be your final answer, because the question was asking you to find the value of W and